Hello everyone, welcome back to the channel. I hope you guys are doing amazing. So let's see today's daily challenge on Leetcode and we will try to solve it together. So first of all, let us try to understand the problem statement. So we are given this question of design task manager. So there is a task management system that allows users to manage their task each associated with a particular priority. Okay, so you need to design a task management system and you are given a task ID, user ID and priority of that particular task, and it is told that the highest priority need to be executed first. Okay, and you are given this vector of vector tasks. Okay, this is the input which you will be given. So it consists of user ID, task ID and priority in this order. Okay, it is already told here. So it adds the task to the specified user ID with a given priority. Okay, so you have some functions like add, which can add a particular task to the specified task ID and priority with user ID, and it is guaranteed that the task ID does not exist in the system. So it is basically what it is saying is that when this add function will be called, okay, so first of all this task will be it will initialize this data structure which will manage this task management, okay, system. Okay, and when it will add a new entry in that data structure. Okay, so the new entry will be in the form of user ID, task ID and priority. It's quite obvious. Okay, and in this edit function what it will do is that they're given an existing task ID, it will return the priority. Okay, so it will it will edit the priority to this given new priority. So if you have a particular task ID whose priority is some X and this new priority is some Y, then you need to replace that X by Y. Okay, so that's what you need to do. You need to update your priority to the new one in this edit function, and for the remove you just need to remove the particular task which is assigned. Okay, so if a particular task is going on with this particular task ID, then you need to remove that. Okay, so if you are using some data structure which has an task ID as its key, so you can just remove all the task IDs, this particular task IDs, and you, execute top. Finally, this is the main function which you need to execute with the task with the highest priority across all the users. Okay, so let's say if there are multiple tasks with the same highest priority, execute the one with the highest task ID. Okay, and after executing the task ID is removed from the system, return the user ID associated with the executed task. If no tasks are available, you need to return -1. So if you try to understand how you can solve this problem, it is quite trivial to actually guess that you need a priority queue in solving this problem, because that is the data structure which helps you determine the top element. So you see an execute top will be called when, okay, so you need to directly take the element which is present in the top of the priority queue. So if you do not know what is priority queue, let me give you a small introduction. Okay, so priority queue is basically it is a queue which is implemented using a heap. Okay, so by default what it does, let's say I'm doing a priority queue of integer. This is how we initialize that. And if I'm doing a priority queue of integers, and if I'm storing something like 5, 2, 3, so the priority queue by default store in this manner 5, 3, 2. Okay, the top element of the priority queue is the greatest element, then the next element is the 3, and then it is 2. So I hope you understand how it actually, so by default it sorts in a reverse manner. Okay, and how does it help? So it see, it is, since it is sorting by default in a reverse manner and you are given some number of queries, if you are asked to directly give me, let's say I directly ask you give me the top element, okay, you can directly access that. You can directly access that from the top of the priority queue. You do not need to traverse the whole priority queue again. Okay, so that's the hint. You need to execute the top element of the priority queue in this function. So that's why you do understand that we need a priority queue in solving this. Now you see what is the, like, we will execute the one with the highest priority, right? It is already told in the question that execute the one with the highest priority. Okay, but you see that if the priority are same, it is also told that if the priority are same, if there are multiple tasks with the highest priority, execute the one with the highest task ID. So now what we can do is that instead of an integer, we can store in the priority queue some pair of integer. Okay, so we can initialize it something like this: priority queue of pair of integer comma integer. I hope you already know this structure, pair. Okay, and what it does is that let's say there are some pairs 5 comma 3, 5 comma 1, 6 comma 2, 4 comma 3. Let's say it has these elements. So what it will do is that how it will store by default by the first value at first. Okay, it will sort by the first value. So which is the highest first value? It's 6. So it will, the top element of the priority queue will be something like this. And now you see the second highest value is 5, but there are two values. In case there is a tie, it will by default store this, the second value, whichever is the highest in the second value. So 5 comma 3 will be that next one, 5 comma 1 will be the next one, and at the very end you will get 4 comma 3. So that's how a priority queue of pair works. Why I am using priority queue of pairs in this problem is quite obvious, is that if there are multiple tasks with the same highest priority, you execute the one with the highest task ID. So what will be our pair of priority queues? This is the priority. I mean, I first need to give my attention to the priority, because the one with the highest priority will execute first, and if the priorities are same, if these two priorities are same, the second element should be my task ID. So this priority queue of pair of integers we will store in the form of priority comma task ID. It is quite obvious to store in this manner. I hope you do understand by now. Okay, why exactly we are storing a pair of priority queue, okay, pair of integer in the form of priority. Okay, so we can directly access this element, and you see there is a catch here. What is the catch? Is that in the remove function, in the remove or in the, let's say, edit function, they will ask you to edit the priority queue of a particular task. Okay, so let's say so first of all they will give you the task and the new priority. So definitely you need to have some mapping from task to the old priority. So let's say I am not using the word old, let's say I am using the word priority only. What you need to do in the edit function is that you need to remove this priority and add my new priority, which will be passed into the function argument. You see, in the function argument it is given that you need a new priority which you need to add it, and you need to remove the old priority. So definitely there must be some map, okay, which maps the task to the priority. Okay, then only you will be able to, remove this. Okay, but let's say you have a task, let's say 5, and the priority is 6. You need to update this priority to, let's say, 8. Then from from the priority queue you might think that I will search for this 5 comma 6 pair, that it will take a log of n time, and then I will remove that pair and then insert this, push this element into the priority queue. So I hope you might be thinking like this, but actually you do not need to do this. Why? You can just keep pushing duplicate elements into the priority queue and just update your new priority in the map. Whenever you are going to execute a particular function, let's say you have this element and you have also this element pushed into your priority queue. Both of these elements are placed in your priority queue, but this is a invalid element and this is a valid element because this was updated, but you do not want to go to the iterate the priority queue whole and again delete this element. Okay, so what you can do, you can just check it from the map whether your priority queue has some mapping, has a valid map. Okay, so initially the map will be 5 comma 6, and then it would have been changed to 8 after this edit function. So you can just see that oh, I am getting this second value as 6, means this is the something which I need to discard it and pop this element from the priority queue. You can do it later during the processing. That is the thing only which I want to say. As I will code, if you are getting confused right now, just bear with me. As I will code will make the things easier. Okay, so you will see how it works actually. And you need to return the one with the user ID also, right? After executing the task ID is removed from the system, return the user ID associated with the executed task. If you read this statement, you need to return the user ID after execution of the task. So definitely for the map, you can also store it in the form of pair priority queue comma user ID. So it will be useful that if you are executing, let's say, task number 1, after the execution you also have the map to the user ID, and you can also return the user ID, let's say it was 3. So what are we doing? What all data structures are we doing in this problem? So see, this kind of design problem is actually very useful for strengthening your DSA concept, data structure concept, because we are using two data structures here. Okay, so one will be the map. Our first data structure is nothing but the map of integer comma pair of integer comma integer. I hope you understand what and what I to what and what I am mapping. I am mapping task ID to priority comma user ID. I already explained you in detail that why exactly we are using this. Things will become more clear as we code. Priority queue, I am also using a priority queue data structure, which is nothing but a heap. Instead of this heap is implemented in the internal of the C++. So and for the priority queue I am using directly the pair of integer comma integer. So I hope you do get that easily. And what is this pair exactly? It is nothing but priority comma task ID, because that is what is asked in the question. You need to sort by this. So the highest priority we need to take it, and if the priority is the same, then we need to sort it by the task ID. So I hope you do get it. I hope you do understand what I want to say, and you can just go ahead and try to implement this in the code. Okay, so I will first of all initialize these two data structures. So these two data structure by default I will initialize it in the private. So yeah, I have it, map of integer comma pair of integer integer, and you have this as a map ID. Okay, so what exactly are you mapping? I will just write it once more. You are mapping a task ID to priority comma user ID. That is what you are provided about a particular task: user ID, task ID, priority. So this map is basically a table. It is a hash table which will store everything. It will store every information about the identified by the task ID. Okay, and this priority queue I am requiring in order to execute the one with the highest priority. So I will have a priority queue, let's say pair of integer comma integer. And as I had told you multiple times, what I am storing in this, tell me, the first element is nothing but the priority, right? The first element is the priority, because the one with the highest priority we will execute first. Now if the priorities are same, we will execute the one with the highest task ID. So the next element is task ID. So yeah, we do that in the priority queue. So we will be given this user ID, task ID and priority in a vector of vector format. We need to I mean add those elements into our map. Okay, map as well as the priority queue. So for that what I will be doing is that I will iterate through, let's say I will use the auto variable and iterate through the tasks. Okay, so for auto is a vector right now. So what all the things you can I mean infer from this vector? You are given a user ID which is nothing but task of 0. You are given a task ID which is nothing but what is it, T of 1, and you are given a priority queue. So you are given a priority which is nothing but T of 2, and what you can do, you see the add function calls and adds everything, right? So you can just call the add function from here only, instead of writing the same thing twice. You can just call the add function which will just add your elements into your data structures. And now you can implement the add function. What it will do is very simple. It will just take the elements and add it. Okay, so into your data structure. My first data structure is a map. Okay, so which will store this task ID. Okay, and it will be storing in the form of this priority comma this user ID, right? So you do have it right now. And for the priority queue, I can do a pq.push. I can do a simple pq.push, and the first element is nothing but the task ID, priority queue, priority comma task ID, right? So priority comma task ID. So I hope you do get it. And how will you edit it? So the addition is very simple. As I had told you, you can go to this particular task ID which you want to edit. So first go to that particular task ID, go to the first element, because the first element in the pair is nothing but the priority. This is the old priority. You initialize your old priority to the new one. It's as simple as that. Okay. So you are initializing your old priority to the new one. Okay, and as of now you are not deleting anything. You are really not deleting anything from your elements. Okay, from your data structures you are not deleting anything. So you just updated this uh, priority. Okay, so yeah, and you need to do something like remove. So what can you remove? For remove you can simply do map.erase. You can simply erase all those elements which are having a particular task ID. So you just use this simple function. So you see you have the 4 functions already implemented, and you need to write the execute function right now. Okay, so definitely for the execute function you need to select the top element of the priority queue, right? So uh, you might be thinking that I will directly select the top element, but the top element may not be valid, because you see when I am editing I am not changing anything in the priority queue. I am leaving the priority queue as it is, right? So I am just pushing element. I am just pushing this new element in the priority queue. So uh, you see I will just push this new element. So there can be duplicacies, right? There can be duplicate values of task ID. Okay, so in the priority queue, so I need to verify that. I need to verify that whether my function is having uh, a valid task ID or not, whether my priority queue is having a valid task ID or not. So it is the thing which I told you here. It's that 5,6 and 5,8. If you are, let's say, asked to change this 6 to 8, you have done it here. You have done change the 6 to 8, and then you have pushed 5,8. You do not need to waste your time iterating while having this 6. Okay, while removing this 6, but now you need to check whether the because 5,6 is now a duplicate and not non-useful value. So you just need to check whether my values are at all useful or not. I'm just keeping a check, okay, whether my elements are at all useful and existent also or not, because I'm also removing some elements from the map. I'm not deleting it from the priority queue. Okay, so I just need to check. So let's say I have the priority queue, and priority queue have things in the order of something like what did I tell you? Priority queue has priority and task ID. So it has priority. So pq dot top, I got the top element and the first element, and it also has the task ID. Okay, so pq dot top dot second, and no matter what you do, you can simply delete the element pq dot pop. You can do a pq dot pop, because anyways you are going to delete the element from the priority queue, whether it is existing or not existing. If it is existing, you will execute and then delete, and otherwise you will simply delete. So anyways this pq dot pop has to be done. Okay, this has to be done. Now we will check for existency, okay, whether it at all exists in the map or not. So I will just tell that if let's say map dot count of this particular task ID exists or not. So if this task ID exists, that is it does not have been deleted, that is its count is greater than 0. And you see you definitely want to check that the map with this particular task ID. Okay, so the map with this particular task ID has the required priority or not. So let's say this comma first does it have the required priority, which is P. Okay, so if it is not, it means that it was edited, its priority was edited, and you need to simply pop it out. So you just need to check that my particular task ID has has this priority or not, and it is existent or not. Then my element in the priority queue is just valid. It is a valid element. Okay, so what I will do, I will execute it. Okay, so it has not been told how exactly you want to execute it, so just execute it right now. And what you need to do, you need to return the one with the user ID. Okay, so let's say I have a user ID which is nothing but this map of this particular task ID dot second. So that's how I get the user ID, and I can just simply erase my element from the map, right? So I can just erase this particular task ID from the map. Okay, and what I can return is that return this user ID, because that's the thing which I need to return after executions, right? So yeah, it's already told the question, return the user ID with the executed task. So after all this, you see, after all of this while loop, if you do not have something which you can return, so you can just simply return -1. That is also told in the question. So I hope it is very clear to you, and I think it will be accepted easily. Let's see. Let's try to run all the codes and check. So you see, we did get the accepted thing. Our runtime and memory are decent. It's not that good, but it's decent. And I mean, I found out this method. If you have something even better one, even a better method which can run in more efficient runtime complexity, but this thing runtime varies a lot. Okay, even with the same code, it gives this different types of percentage bits. So yeah, I hope, I personally think this is the most optimal way to do it, because priority queue takes a log of n time for insertion, deletion, and also this map, right? So instead of this map, what you can do is unordered map, because it takes an amortized O of one time complexity. Do you think it will cause any error? I don't think so, but let's try to run it and check if it improves. So you see, it did actually improve the runtime complexity, and we now have a quite decent runtime. So yeah, that's all, I guess. That's all for this problem, and I hope this problem was very clear to you. If you did not understand, definitely ask me in the comment section. So yeah, that's all for this video, and I hope you have a wonderful day ahead. Thank you so much.